What we have learned so far is that to calculate the quantity of heat in a substance, we simply use Q is equal to mc delta T. But does this equation always work in every situation? So does it work in all situations? And the answer is no. Where will this equation not be applicable? This equation will not work if we have a change in state of matter. It will not work when a change in states or in state of matter is occurring. Let us take a look at the changes in states of matter that we can have. If you have a solid and you want to change it into a liquid, the process by which that occurs is called melting. Melting is an endothermic process because you would need to supply energy to a solid to break the particles of the solid apart to form a liquid. The reverse of melting is called freezing. Freezing is an exothermic process because to get a liquid to freeze, you would need to suck some kinetic energies away from the particles of the liquid so that it can become a solid. Both melting and freezing require the same amount of energy, just in opposite direction. In one case, the system is losing energy into the surroundings. In the other case, the system is absorbing energy from the surroundings. The exothermic process is usually given a negative sign, while the endothermic process is usually given a positive sign, but they would have exactly the same value because they are equal but opposite. Also, if you want to change a liquid into gas state, the process of doing that has many names, but we're going to go with boiling. But you can also call it vaporization, and some people even call it evaporation. To change a liquid to a gas, you would need to supply energy to the liquid. So, boiling is an endothermic process, which means that the energy change required would be positive. The reverse of boiling, which would be if you want to convert a gas back to a liquid, is called condensation. Condensation is an exothermic process, which means the system would lose energy into the surroundings. Both boiling and condensation are equal in energy, but they are occurring in opposite directions. So exothermic will be negative value. If you want to change a solid directly into a gas without first forming a liquid, that process is called sublimation. To change a solid directly into a gas, you would need to supply energy to the solid. The solid is a system. So sublimation is an endothermic process. If you want to reverse sublimation, which means you want to go directly from a gas to a solid, that process is called deposition. And deposition is an exothermic process. When all of these changes in states occur, they always occur without a corresponding change in temperature. That is why Q equals to mc delta T will not be applicable when all of these changes in state occur, because delta T at that point will be 0, which means Q would be 0. And we know that energy is being used, for example, to freeze or melt a substance. So Q is not equal to 0. It is just that this equation does not work. So how do we calculate the energy when a change in state is occurring? To do that, let us take a look at the heating curve for water. Let us draw a curve. The vertical axis, let us label that as the temperature axis. And the unit will be degrees Celsius. The horizontal axis, let us label that as Q, which will be the amount of energy added in joules. The point at which they meet right here, let us label that as 0.00. If you open your freezer at home and you grab some ice from the freezer, let us assume the temperature of the ice is -5 degrees Celsius. And then you put the ice in a container and you put it on a stove and you begin to supply energy to it. As you supply energy, the temperature of the ice will increase. It will continue to increase until it reaches a transition point, a point at which the solid ice needs to melt. For water, the melting point is at 0 degrees Celsius. So at this point, we have ice. Still at this point, we have ice. But the temperature of the ice is now at 0 degrees Celsius. And as you supply more energy to the ice at 0 degrees Celsius, the temperature will remain constant. That is why this is flat. And that temperature will remain constant until the ice is completely melted into liquid water. Now we have water at 0 degrees Celsius. As you continue to supply more energy to the water, the temperature of the water will begin to rise. It will rise until it reaches another transition point, the point at which liquid water will need to boil. So at this point, we still have liquid water. The transition point, the boiling point for liquid water is 100 degrees Celsius. So let us label this point as 100 degrees Celsius. As you supply more energy to the liquid water at 100 degrees Celsius, the temperature will remain constant as the liquid water changes to steam, which is a gas. The curve will remain flattened until all the liquid water have been changed to gaseous water, which is steam. And at that point, the temperature will begin to rise again when everything is steam. So at this point, you still have water, but at gas state, which is what we call steam, at a temperature of 100 degrees Celsius. And the temperature of the gaseous state of water will remain increasing until the H2O is split apart. In all of these points where the temperature remains constant, Q is equal to mc delta T will not work. Let me label them carefully so that we can see them. This point is the melting point. If we're going from the ice to the steam. But if we're coming down from the steam to ice, that point would be freezing. So melting or freezing. This point is the boiling point. Or condensation, if you are coming down from a gas to a liquid. For these 2 points where the temperature is not changing, we would have to use another equation to determine Q. Q will be equal to the mass of the substance multiplied by what is called the latent heat of the substance. What does that mean? Depending on whether you have melting or freezing, or boiling or condensation, latent heat will be different. If you have a solid changing into a liquid, the latent heat will be what is called enthalpy of fusion. So this is the case when you are going from solid to liquid, or vice versa. On the other hand, if you are boiling a liquid to turn it to a gas, the enthalpy change is called enthalpy of vaporization. That is when you are changing from liquid to a gas, or vice versa. So this is the new equation that we're going to be making use of. Q is equal to mass times latent heat, and the latent heat will depend on whether we're melting or whether we are boiling.